Look at a giant cargo ship crossing the ocean. From the surface, it looks simple. Steel, containers, engines, and a hull designed to carry thousands of tons across the world. But there's a strange detail hiding underneath. Above the waterline, a ship can be almost any color. Light, black, blue, gray. But below the water, very often, red. And once you notice it, you start seeing it everywhere. So why? Is red somehow better at surviving underwater? Does it make ships easier to see? Or is there a completely different reason? Because the answer begins with something that happens the instant a ship enters the ocean. The ocean starts trying to live on it. At first, the hull is smooth and clean. Then microscopic organisms begin attaching themselves to the surface. Algae follows, then larger organisms, and eventually, barnacles, mussels, and other marine life can cover parts of the underwater hull. It sounds harmless. It isn't. A ship's hull is carefully shaped to move through water with as little resistance as possible. But imagine taking that perfectly smooth surface and covering it with thousands of tiny bumps. Water no longer flows around the hull as cleanly. Drag increases. And when drag increases, the engines have to work harder to keep the ship moving. More power means more fuel. So something as small as a barnacle can eventually become a very expensive passenger. But marine growth is only half the problem. There's another enemy underneath the waves, and you can't even see it happening. Corrosion. And this is where the strange paint comes in. Because the red coating you see on the bottom of a ship isn't ordinary paint. The underwater part of the hull can use several layers of specialized coatings. Some are designed to protect the steel. Others are designed to stop marine organisms from establishing themselves. That second job is called antifouling, and humans have been fighting this problem for a very long time. Eventually, one material became especially important: copper. Certain copper compounds are highly effective at controlling many organisms that try to attach themselves to underwater surfaces, and one compound became particularly associated with traditional antifouling paints: cuprous oxide. Now look at its color, reddish-orange. And suddenly, our mystery starts making sense. The famous red bottom isn't red because ships need the color red to survive. It isn't a warning to barnacles, and it isn't some secret maritime rule. The color is largely connected to the materials and pigments historically used in antifouling coatings. In other words, the chemistry came first. The color became the signature. And there is an important detail most people miss. Not every ship has a red underwater hull. Modern antifouling coatings can come in different colors and use different technologies. So if a ship has a blue or black bottom, that doesn't mean it has abandoned the idea. The important part isn't what the coating looks like, it's what the coating does. But then, the industry discovered another problem. If a coating is powerful enough to stop marine organisms from living on ships, what happens when those chemicals enter the ocean? History gave us a very uncomfortable answer. One of the most famous examples was tributyl tin, or TBT. It was extremely effective at preventing marine growth, but it was also extremely harmful to marine ecosystems. It caused serious biological effects in marine organisms, and its use on ships was eventually banned internationally. Because here's what makes this whole thing fascinating. That red section of a ship looks like decoration, but it is actually part of the ship's defense system. Above the waterline, you see the ship's cargo. Below it, you see the battle. Steel versus corrosion, a smooth hull versus thousands of organisms, engine power versus drag, and all of it is happening beneath the surface where most people never look. So, the next time you see a massive ship with a red bottom, don't think of it as just a paint color. Think about what that thin coating is doing. It's helping keep the hull protected. It's helping prevent the ocean from turning the hull into a living surface. So, why are ships painted red below the waterline? The surprising answer is they aren't painted red because red itself is special. They're protected by specialized underwater coatings. And that familiar red color is largely a historical consequence of the copper-based materials that became common in anti-fouling paint. So, the next time a ship passes you, look at the part you normally ignore, because beneath that red line is an entire engineering system quietly fighting the ocean, and the ocean doesn't even know it's losing.